Now, if you didn't watch my previous video regarding the factory pattern, I recommend watching it. It goes over how to instantiate objects by specifying which object that you want. In this video, I'll be going over a more advanced version of the factory pattern, which leans on more of an abstract approach called the abstract factory pattern. So why is abstraction good? Well, first, it improves code reusability. As we'll see soon, it will allow for common components to be reusable throughout the application, and it reduces duplication of code. 2. Clear design. It allows for the code to be broken down into easier consumable chunks, which will allow for better understanding of how pieces are working together. Also, usually being a generalist is considered bad, but not in the case of code. Being able to fit a piece in different engines make for cleaner and clearer design. And third, easier to maintain. Because the abstraction will force the need to break bigger code into chunks, it will make it easier to make additions instead of trying to force a piece into the non-abstract code. And the core will stay the same, while the abstraction layer will work with the core for better security. What is an abstract class? An abstract class works as a blueprint for classes, and it is useful especially when you find common properties that those classes have. An abstract class can't be initialized, but those that inherit a abstract class must implement the methods created in the abstract class, which we'll see soon. So here I am in VS Code. You can use whatever editor that you want. I just like VS Code, and you can already see that I still have my factory pattern file up from the other video, but I'm gonna close this out, and I'm gonna create a new file called abstract_factory_pattern.py. So in this example that I'll be using in this video, I'm going to be creating an upgraded version of the zoo factory that I created in the factory pattern example. And I'll be creating an abstract base class called the zoo animal, because every class in the zoo factory will be a zoo animal. Now I'll be utilizing the Python ABC module, which will help define abstract base classes. I will use the ABC helper class from the ABC module to create the abstract base class of a zoo animal, and utilize the abstract method annotation to define the abstract method. So let me go ahead and do that instead of just talking about it. So from ABC, let me import ABC and the abstract method. Go. And now what I'm going to do is I'm going to define a abstract class called zoo animal, which we'll utilize for every zoo animal in the zoo. So this is going to be our abstract base class, right? This is going to be something that all the zoo animals share, like all the properties that the zoo animals share. This is going to house all of those properties. So in the factory pattern example, we saw that animals usually have a color and they usually have a calling, meaning the noise that they make. So this abstract class will hold that, and every animal that we create for the zoo will inherit those properties because they're a zoo animal and they have those properties. So let me go ahead and define that this zoo animal is going to inherit from ABC, which is going to just be the helper class from the ABC module. And then let me go ahead and use the abstract method annotation to go ahead and define these properties that every zoo animal is going to have. So first is going to be color, because like I said in the last example that I created in the factory pattern, every animal had a color, right? And it was of type list because every animal has multiple colors. Well, not every, but most animals have different types of colors, or it might be different shades of a color, but usually it's very distinct. So let me go and do that. It's going to be a list of colors, and if it's just one color, then I just return a list of just one length or one color. And because this is the abstract method, it is not going to have any code within it. It's going to have to be implemented from the animal that's inheriting this zoo animal. So I'm going to go ahead and pass this method, right? It's not going to have anything. It's not going to return anything. The next abstract method I'm going to define is going to be the calling, right? Because usually an animal makes some type of noise. So in the last example, a lion roared or a giraffe hissed when it feels like it's in danger, but that's a calling. So I'm going to go ahead and create an abstract method called calling. And what it's going to do is going to return a string. A string, str. So what happens when you use multiple languages, you forget that it's str in Python. So go ahead and pass that, and we're good to go. So these are the two abstract methods that we expect every animal in the zoo to implement. And so whenever I create a thing like a lion or a giraffe, they have to instantiate these methods with whatever color that it has or whatever calling that it has. For color, it has to return a list, and for calling, it has to return a string. So let's actually go ahead and create those animal classes. So just to save time, I'm just going to go ahead and paste in those animals that I created in the last example. So there's going to be lion and giraffe, and you can see that it's going to be inheriting from zoo animal, which is up here, and we can see that it's defining color already, and it's defining calling for the methods that have to be implemented because we created it in this abstract class, right? And the same thing for giraffe. It has color already and it has calling, but we don't want to have such a basic zoo. We're going to create two new animals, and we're going to define those methods, those abstract methods. So the first new animal that's going to be a part of the zoo is going to be the adult emperor penguin, right? Because the reason why I'm saying adult emperor penguin, because a young emperor penguin does not look like the adult version. The young one looks all fuzzy. It's huge, but it's all fuzzy and it's gray. But the adult one has more distinct colors, so I'm going to define that one. And because we're utilizing the zoo animal, we're going to have to use the color and calling method that we defined here as abstract methods. So let's go ahead and do that. So for color, I'm going to define color as an instance of itself, and it's going to return a list, right? And it's going to be black, that's one of the colors, white, orange, and gray. And then for calling, what I'm going to do is I'm going to return the noise that an emperor penguin makes, which is squawk. I'm pretty sure they make a lot of other type of noises, but that's just the distinct one that I remember. And lastly, the next animal that we're going to create in the zoo is a personal favorite, which is a panda, right? So let's go ahead and create a panda class, and we're going to use the zoo animal because it is a zoo animal, and we're going to define the color. And luckily, a panda is very basic in regards to color. It is simply black and white. And we're going to define the calling, which is the noise that it makes. And personally, I only ever heard a panda huff. I'm not sure if they roar, they probably do, but a huff is what I'm going to define here. So now we have our 4 animal classes. We defined 2 new ones, adult emperor penguin and panda, that's going to implement the abstract class that we defined, right? Because we know that all these zoo animals have these similar properties, right? We know that each zoo animal has a color and each zoo animal has a calling. So when you know that it shares similar properties, go ahead and utilize an abstract class. So now all you got to do is just instantiate it within the class itself, right? But this is essentially the blueprint, an extra blueprint for a class. So now that we created the animal classes, we can now create the abstract zoo factory, and we're going to create it with a onboarding system that allows for the onboarding of new zoo animals and the ability to get an animal from the zoo inventory. So if you want to onboard a new zoo animal to the zoo factory, it is now easy to do and manage, right? Because before we were restricted to just lion and giraffe, because if I go back to the factory pattern, you can see that you have to essentially create a branching system that say, okay, this is going to be, this is going to return an instance of a lion if it equals to a lion, and this is going to be equal to a giraffe if it equals to a giraffe. But we're unable to add additional animals if we wanted to, so we're kind of restricted to just these 2 animals. But in the new abstract factory pattern, we're going to be able to onboard new animals if we want to, because now we have pandas and we have an adult emperor penguin, and we want to onboard them because they came from another country. We want to bring them into our zoo without having to rewrite the whole code base here. We could just onboard it into our inventory. So let's do that. Let's go down below here and let's start that process of creating the abstract zoo factory. So let's do class abstract zoo factory, and I'm gonna create, initialize a zoo inventory. So I'm gonna use the init for that, and it's gonna take an instance of itself, and I'm gonna do self dot underscore zoo inventory. This is gonna be the inventory of classes, right, that we created for the animals, right? So, if we have a penguin in our inventory, then it's going to be in the zoo inventory. If we have a lion, it's going to be in the zoo inventory. So any animal that we have in the zoo is going to be within the zoo inventory. So it's going to be a dictionary, and we're going to define the key as the name of the animal, and the value going to be the class. Now to onboard an animal, we'll create a onboard method. So we'll call this onboard animal. It's going to take an instance of itself, animal name, animal. Nice. And what we could do is we could do self dot zoo inventory, and like I said, the key is going to be the name, right, the animal name, and I should define that it's going to be a string in this case. And it's going to be equal to an animal, right? And in this case, it's going to be a zoo animal, of type zoo animal, right? Because we know that all these animals that we created at the base level, they're all a zoo animal. So it works in this case. So if we want to onboard any new animals, say for instance, we're at a zoo and currently only has a lion, that's boring. But we want to onboard a giraffe. Well, all we got to do is pass the key as giraffe, and it's going to be equal to the class, right, of giraffe. So now we have a lion and we're going to have a giraffe, and we're going to see that pretty soon. And the second method we're going to define is getting the animal, right? We want to get the instance of that animal, right? If we have it, then return it, right? So it's going to be self and animal name that we want to retrieve. And then animal is going to be equal to the self dot zoo inventory, and we're going to get that animal by the animal name, right? Now if not animal, meaning if there's nothing in this animal, right, there's no values, didn't return anything from the zoo inventory, then we could raise a value exception or value error, and that's just going to return a formatted string of animal not available in zoo, and we could define the animal name here. And if we do have an animal, that means it's going to skip this branch here. We can go ahead and return an instance of that animal, and we're good to go. And one final method that we can actually create is we could actually just see the inventory. So see inventory, and what I'm gonna do is it's just gonna return, or it can return, a list, right? So I'm gonna return the self dot zoo animal or zoo inventory dot keys, and this is just gonna return the keys of the animals that are in the zoo inventory, right? I don't want to return the classes, right? So I could have just returned the whole zoo inventory, but I don't want that. I just want to return the keys, because we know the keys are simply going to be the animal names. So I want to see if I have a lion, giraffe, whatever, or if I just have a lion, then I'll just see that, in the keys, and that's going to be simply going to be a list, right? So now I know, before I ask it for it, I can check the list or the board. Every zoo has a board, showing where to go. What I could do in this case is I can go ahead and go to that board, and what that board is going to show is an outputted inventory of the animals that we expect to see in the zoo. And by returning the keys, I can see that. So cool. Now we have the abstract zoo factory. We initialized it with a initial instance of the zoo inventory, which is going to be empty at first. but we can go ahead and onboard animals as they come into the zoo, right? Maybe we have good funding, we're able to get as many animals as possible. We can go ahead and onboard that. And then if we want to see a specific animal, we can get the animal by the animal name if it's in the zoo inventory. If it's not, then it's going to raise a value error saying that animal is not available in the zoo. And if we want to be able to see the whole inventory of what animals that we expect to see in the zoo, we can go ahead and honestly, probably this will make sense as get inventory or get zoo inventory. And we'll be able to grab all the zoo animals that we can see in this specific zoo. Cool. So now we have the abstract zoo factory. We had the basic implementation of factory pattern. Now we have the abstract factory pattern. But you want to know why this is awesome? Because with this abstracted factory, we can now use it to create multiple zoo factories for different zoos all around the globe, because we are not restricted to just the animals created from the start in the factory anymore. We can now onboard animals and create new instances based on where we are. Because with the regular factory, you would have to make multiple different factories to satisfy different zoos. And even if we created multiple zoo factories for specific zoos, what happens when we need to onboard new animals? Well, that's not possible, right? We would have to go in, add that branch to the zoo factory, because remember, like, it's a branching system, right? There's checks to see if there's a lion, checks to see if there's a giraffe. But if we want to add a penguin, we're gonna have to go into the code and add that, right? We can't just go and call a method. We actually have to manually add that, which is different than the abstract factory pattern, which will allow us to just call a method internally, whether it be from an HTTP request or wherever, or from a DB somewhere. We can call a method to onboard it or onboard an animal, unlike the factory pattern, which is a very basic version, right? We now created an abstract version of it, which will allow us to define zoo animals and onboard those zoo animals. And it can be different per zoo. So with the abstract factory, we can now create different instances of zoo factory, and based on the location, we can onboard new animals, because most zoos have different animals. For example, the New York Zoo does not have a panda, but the Shanghai Zoo does have pandas. So let me create a couple of abstract factories to show how amazing it is. So I'm going to wrap this all in a try and accept, because it does have the ability to return a value error. So I want to be able to capture that if it does. So I'm going to capture a value error as error, and if it does, then I'm going to print out that error. And in here, I'm going to go ahead and try to create those different zoo factories, and we can go ahead and onboard what we need to onboard based on that specific zoo. So the first one I'm going to do is the New York Zoo Factory, and that's going to be equal to the abstract zoo factory. And with this abstract zoo factory, what I could do is I could do NY New York Zoo Factory onboard animal, and I could define the key, right, of penguin as the animal name that I want to onboard, and I could define that the animal, like the blueprint of that animal, is going to be the adult emperor penguin, right? So now I'm onboarding a penguin to the New York Zoo Factory, and I want to onboard another animal to the New York Zoo Factory, and I'm going to onboard a lion, and that blueprint for that animal is going to be lion. And this is all possible because they're all zoo animals, right? So that abstraction makes it so useful, because if I didn't have that zoo animal attached to each animal that's a part of the zoo, then this portion will be impossible. The next thing that I want to do, like, little Timmy is now at this New York Zoo. I want to get that penguin from the New York Zoo Factory, right? I want to get that penguin from the New York Zoo, and I want to see what color the penguin has and what calling that the penguin has. So what I can do is I can grab that penguin. I'm going to call this the New York penguin, and that's going to be equal to the New York Zoo Factory dot get animal, and the animal name is penguin. And what I can do here is I can print the penguin's color, or the New York penguin color, and I could print out the New York penguin dot calling. What type of noise does that New York Penguin makes. So let me go ahead and save this and print that out and see, or run this. So it's going to be the abstract factory pattern.py. Press enter, and boom, it's working as expected. I can see the color of the penguin, and I can see that it squawks. Now, say for instance, I got on a plane and I'm going to China, Shanghai specifically, because I want to see a panda in real life. Well, I can go ahead and create a Shanghai zoo factory, and it's going to be equal to an abstract zoo factory. And what I'm going to do at this Shanghai zoo factory is I'm going to onboard an animal. I'll call it panda, and it's going to be the blueprint of a panda. Alright, so also in the Shanghai zoo factory, we're going to onboard a lion. So let's do onboard animal, call this a lion. That's the animal name, and the blueprint for this animal is a lion. That's also a zoo animal. And then we're also going to onboard a penguin. And it's going to use the adult emperor penguin. If you had a baby emperor penguin, you can go ahead and create a blueprint for that and onboard it here. So go around and play with the classes and the factory and see what works for you. But in this case, I'll be using the adult emperor penguin. And what I want to do is I want to see the panda. That's what I came all the way to Shanghai for. Took an airplane from the United States to Shanghai because I want to see a panda. So what I'm going to do is I'm going to do panda, or specifically a Shanghai panda, and make that equal to the Shanghai Zoo Factory get animal, and specifically the panda. All right. And what I want to do is print out, and I'm going to say print panda attributes. And what I'm going to do is I'm going to print out the panda, or the Shanghai panda. Keep making that mistake. Shanghai panda dot color, because I want to see what color is a panda, and I want to see or hear the calling of the panda. So the Shanghai panda dot calling. What noise does the panda make? And then lastly, right, I saw the panda. I'm happy that I saw the panda. But what else does the Shanghai Zoo Factory has to offer? Like, what else does this zoo in Shanghai has? Right? What's their inventory of animals? Sounds wrong, but yeah, exactly. Like, what is the inventory of animals that this zoo has? So we can print out that, right? Let's walk to the board and see what location and what animals are in the zoo. So we can do Shanghai Zoo Factory dot get zoo inventory. And one thing I'm going to do with this get zoo inventory is, yes, it's going to return the keys, but it's going to return a dictionary, the dictionary keys, but I got to convert that to a list, right? And that should work. So just to go over it, right, we have a New York Zoo Factory. We onboarded some animals. We're printing the New York penguin, right? We retrieved the penguin and we're printing that out. We got the zoo factory for Shanghai because we took a flight to Shanghai to go to the zoo, and we onboarded a couple of animals to that Shanghai zoo. And now we want to see specifically the panda, which we are asking for. Get that animal, get that panda, and we're printing out the attributes of that panda because we want to see what color is the panda and what's the noise that the panda makes. And then we want to see what else, what other animals that the Shanghai Zoo has to offer. So we're printing out the inventory. So let me run this really quick. Python 3 abstract factory pattern, and we can see the first two lines are attributes and the calling of the penguin. And then here we have the panda attributes, which we see that it is black and white and it makes a noise of huff. And then the inventory of Shanghai is panda, lion, and penguin, because here we see that we onboarded 3 of these animals. So that is the inventory of the Shanghai Zoo. So cool, it is working as expected. Now, what happens if we try to get an animal that the Shanghai Zoo, or ask for an animal that the Shanghai Zoo does not have? Well, let's see that. So let's do print, and let's do Shanghai Zoo Factory dot get animal, and let's do, and which animal does, so we got panda, we got lion, and we got penguin, but let's try to get a giraffe. Right, giraffe. And let's go ahead and run that again. Let me clear this out. Boom. Animal not available in zoo. Giraffe. The animal's not there, right? We only have panda, lion, penguin. We see that in this list right here, panda, lion, penguin. But little Timmy was a little aggressive and he wanted to see a giraffe, and you know, it's just not available. Or say for instance, you know, you just really like pandas, so you can't really afford the Shanghai ticket. It's pretty expensive, I'm not gonna lie. So you try to go to the New York Zoo, right, and you try to get a panda. Like, you want to see the panda, so you ask for a panda, and you know, you want to see it, so you run it, and well, that animal is not available in the zoo. There's no panda in the New York Zoo, right? So we are able to create a factory, right, and we're able to onboard exactly what we need in that factory, like different products or the different animals in this case, and you can ask for a specific thing that you onboarded previously, and it will return an instantiated version of that thing that you onboarded. So whether it's a panda, a lion, you know, penguin, or in a real case, whether it's a, you know, logging instance, whether it's a database instance, if you onboarded it and you asked for it, you'll be able to retrieve it. It will return an instantiated version of it. But if you didn't onboard it and it's not available, well, we have this try and accept that will make sure that we're going to try to get it from the factory, but it may throw an error saying that it doesn't have that value because it wasn't onboarded. We don't have that. We're unable to create what you didn't onboard, right? So that is the power of an abstract factory pattern. The fact that it can instantiate things that, you know, that you want, right? You have it in one, like you onboard things in one go, and in the future throughout your application, wherever you need that instantiated version of whatever you onboarded, it's available. And you're not just restricted to just one factory like we were with the factory pattern, where whatever animals that we had initially or whatever classes we had initially is what we're stuck with, right? Whether we start off with lion, giraffe, we're not going to be able to get an adult emperor penguin, or we're not going to be able to get a panda because we're stuck with this, right? These are the branches that we created initially, and that's it. We're unable to onboard new classes. But with the abstract factory pattern, well, we're able to have an inventory, we're able to onboard animals, and we're able to get them, right? We're not just restricted to what we created initially. We're able to add as we go. So that is the power of abstraction, right? Because all of these, the reason why we're able to onboard these animals is because they're all zoo animals, right? Because we have an abstract base class that specified the properties that a zoo animal has, and we pass it to each individual animal, and because of that, we're able to onboard that animal to our zoo inventory. So you see the power of abstraction, right? And we're not restricted to just creating one type of zoo or one type of factory, right, for just one place globally, right? We're able to create different zoos because there are different zoos all over the world, right? So that's an abstraction, and it's easy to be able to go look into the code and see exactly what it's doing, because we made sure to split up in different pieces, but it all makes sense, right? Because we know that, okay, the base class is a zoo animal, meaning that this is what these are properties that each zoo animal will have, and these properties should probably be injected. This zoo animal base class should probably be injected to the actual animal, right? Because this animal is going to belong to a zoo. This is going to be a zoo animal, and then based on that, the zoo inventory is going to be full of zoo animals, right? So all these little chunks make sense in a bigger picture. And now it's easy to just go ahead and create a class of, let's say, rhino, and that would be also a zoo animal. If it wasn't a zoo animal, then we're not going to assign it the zoo animal base class. But if it is a zoo animal, then we can go ahead and assign it that, and we know for sure that each zoo animal will have these properties, and we can go ahead and define those properties and add it to the inventory if that location has that animal, right? So that is the power of the abstract factory pattern. And this can be used for any example. It doesn't have to be regarding animals. It could be configuration, logging, anything. So it's just based on needs. So nice. Now you see the real power of the abstract factory pattern, especially compared to the normal factory pattern, which hinders the growth based on future needs. This is why when you're coding, you need to think about future maintenance, reusability, and clean design. Those are properties abstraction brings to an application. Hope that was helpful. Thanks for watching.